Assalamualaikum warahmatullahi wabarakatuh. We are going to show you about our project coolant temperature sensor. And here is our group member.
Alright, now for our project is about a temperature sensor. Alright, what is a temperature sensory type? Temperature detection is the foundation of all advanced temperature control and compensation. The temperature detection circuit itself monitors ambient temperature. It can notify the system either of the actual temperature or if detection of the circuit is more intelligent. When a temperature control event occurs, the sensor will detect the temperature and send it to a millimeter, for example. So, there are four types of main sensory type of temperature. They are first, negative temperature coefficient thermistor, or else NTC. There are resistant temperature detector, RTD, which we learn in control engineering by Dr. Musa. Then there are thermocouple and there are semiconductor based sensory temperature. Alright, for our experiment, we use a negative temperature coefficient thermistor where it is thermally sensitive resistor that exhibits a large, predictable and precise change in resistance correlated to variation in temperature. How? Well, you will see this in our next video.
So this is the coolant temperature sensor, or also known as CTS. It is used to measure the temperature of the coolant or anti-freeze mix in the cooling system, giving an indication of how much heat the engine is giving out. So the sensor works with the vehicle's ECU, which they continually monitor the coolant temperature to make sure the engine is running at optimum temperature. To get an accurate reading of the current engine temperature, the ECU sends a regulated voltage to the CTS. The resistance of the sensor varies with temperature. This is how the ECU can monitor temperature changes. The ECU uses this reading to calculate the coolant temperature and from there adjust the fuel injection, fuel mix and ignition timing, and controls when the electric cooling fan is on or off. And also this information is used to send an accurate reading of the engine temperature to a gauge on the dashboard.
This figure illustrates the main circuitry to the coolant temperature sensor. With a coolant temperature sensor, the full sensor is located in a coolant passage that sits before a thermostat and is connected to the engine control and monitoring unit. A basic functional principle to a coolant temperature sensor begins with the ignition switch. When the ignition switch is on, a voltage passes through the resistor and heats up this resistor. The resistor is connected to an electrical grid and this behaves like a data logger measuring the temperature difference of the resistor.
So these are the materials that we use in our experiment. So the first is the sensor itself, the coolant temperature sensor. And next is set, which requires an induction cooker and a pan, which we use to supply heat and to manipulate the temperature in this experiment. Next is water, which we use and act as a coolant, and the multimeter, which we use to display the resistance value at certain temperature, and 4 sets of connecting wires. So this is how we set up the apparatus for the experiment. So first we have to connect the connecting wires to the multimeter and clip it to the bellows of the sensor, and one end at the switch case. So this end is the temperature sensor bulb. This end will be dipped in the water and to detect the temperature and measure the resistance value.
This is the first experiment. This experiment will be act as the control variable. So we have all the tools here. We have the heat sensor, we have the multimeter, we have this pen as the medium, so we can put the water. We have normal temperature water. So firstly, we have to make sure that the water is not heat up and this pen is also cool or in normal temperature. So firstly, I will open the multimeter. As you can see, this is normal room temperature. So, and then I will pour the water into the pan. And that's enough. So, I will dip the sensor into the water. So, as you can see, this is the normal temperature resistant for normal temperature water.
Okay, firstly we will dip the tip of the sensor through the boiling water. As the sensor is dipped, the result will be shown at the multimeter. This further experiment will show you the situation when the car is slightly overheat. In a situation when you are driving from JB to KL in a 3 hours driving, the engine will tend to slightly increase in heat, and this experiment will show you the situation when the temperature is increased from 80 to 120 degrees Celsius. We will dip the sensor in the water. So as you can see, when the sensor is dipped in the water, it will result in the difference reading of resistance. As you can see, the higher the temperature, the lower the resistance will be recorded.
This is the graph of resistance against temperature. When the temperature is increased, the resistance will be decreased. All in all, what we can conclude that there is an inverse relationship between the electrical resistance and the engine coolant. When the engine coolant temperature increases, the electrical resistance decreases, and this is also cause a voltage drop in the sensor. Let's imagine in the cooler temperature sensor to be cold. In the event of flight or no acceleration to the vehicle engine, the resistance of the sensor will be high. As soon as the driver puts his foot down on the accelerator, the engine will begin to warm up and the resistance of the sensor will drop.
And that is the end of our video. We hope you enjoyed. And please like and subscribe to our channel.